We'll solve x to the 9 minus 1 equals 0. We will solve for x, and that is find all the solutions, that is all the roots. We're going to use Trigonometry De Moivre theorem. Obviously, x equals 1 is the answer. That's one of the solutions. And that's not good enough in the scientific world, in the real world, where technology is created, where research and development is done. I'm talking about higher education, where software and hardware and technology are created. In that case, detail is important. That is, x to the 9 minus 1 equals 0. That is to the power of 9. That means you have to have 9 solutions. One of them is obviously x equals 1. Here are the 9 root solutions of x to the 9 minus 1 equals 0. And they are x equals cis 0 degree, cis 40 degree, cis 80 degree, cis 120 degree, cis 160 degree, cis 200 degree, cis 240 degree, cis 280 degree, cis 320 degree. Those are the 9 solutions, the 9 roots. Then you have cis 360. 360 minus 360 is 0. That means cis 360 is the same as cis 0. They are coterminals. Then the next one will be cis 400. Cis 400 minus 360 is cis 40. Cis 400 is the same as cis 40 degree. The next one will be cis 440. Cis 440 minus 360, it is cis 80 degree. So that means cis 440 degree is the same as cis 80 degree, and so on. So this goes to infinity. There are infinity many of them. The basic ones are the 9 roots, but they repeat, they go in circle. So what that means is we are trying to solve for x equals 9th root of 1 plus 0i, and that is the complex number. 1 is the real and 0i is the imaginary. So 9th root of 1 plus 0i is equal to 9th root of cis 0. This 9th root of cis 0 is equal to cis beta, and we'll know what beta is. So now notice that r cis theta is equal to r cosine theta plus I r sine theta. R cosine theta is x, I r sine theta is I, r sine theta is y. So this is x plus iy, that is real plus imaginary, and it is called the complex. Here are the solutions. You start with cis 0, cis 40, cis 80, cis 120, cis 160, cis 200, cis 240, cis 280, cis 320, and that is a unit circle with x-axis is real and y-axis imaginary. This circle is divided into 9 sectors. Each sector is 40 degree. And here is an example of complex number. Complex number square root of 3 plus I. You have r equals 2, that is the vector with magnitude is 2, and direction is pi over 6, which is 30 degree. Then this is r cis theta. that is 2 cis pi over 6, which is 2 cis 30 degree. So that is 2 cosine 30 degree, which is 2 times square root of 3 over 2, which is square root of 3. Then I 2 sine 30 degree, which is 2 times half, which is 1 times I, that is I. Then this is a complex number, square root of 3 plus I, which is a vector with magnitude r equals 2, and the direction is theta equals pi over 6, which is 30 degree. So now if you want to verify that these are solution of x to the 9 minus 1 equals 0, then you can plug this into calculator TI-84. If you put cis 0 degree to the power of 9, then you will get 1. In fact, here you don't even need a calculator. This is cosine 0 degree plus I sine 0 degree to the 9, and that's equal to cosine 0 degree is 1, I sine 0 degree is 0, so that's 1 plus 0 to the 9, which is 1 to the 9 equals 1. Now, if you put in the calculator cis 40 degree to the 9, which is cosine 40 degree plus I sine 40 degree to the 9, you will get 1. Cis 80 degree to the 9, that is cosine 80 degree plus I sine 80 degree to the 9, you will get 1. Cis 120 degree to the 9, that is cosine 120 degree plus I sine 120 degree to the 9, you will get 1. Cis 160 degree to the 9, that is cosine 160 degree plus I sine 160 degree to the 9, you will get 1. Cis 200 degree to the 9, that is cosine 200 degree plus I sine 200 degree to the 9, you will get 1. Cis 240 degree to the 9 equals, that is cis 240 degree plus I sine 240 degree to the 9, you will get 1. Cis 280 degree to the 9, which is cosine 280 degree plus I sine 280 degree to the 9, that is equal to 1. Cis 320 degree to the 9 equals cis cosine 320 degree plus I sine 320 degree to the 9, you will get 1. Now let's go do the detailed solution. Thank you. Find roots of polynomial equation x to the 9 minus 1 equals 0 using Trigonometry De Moivre theorem. Find all roots solutions of polynomial equation x to the 9 minus 1 equals 0 using Trigonometry De Moivre theorem, that is roots of complex numbers x plus iy, which is x equals 9th root of 1 plus 0i, that is equal to 9th root of cis 0, that is equal to cis beta, and we'll know what beta is. X to the 9 minus 1 equals 0. Find the roots. X equals quotient mark. So the obvious one is x equals 1. So x to the 9 minus 1 equals 0. X to the 9 equals 1. Take 9th roots of both sides. Then you get x equals 1, that is the real. What about the other 8 root solutions? Again, we are talking here about real world. Real world means in higher education, research and development, and high-tech corporate world where technologies are created. In that case, we need detailed solution. It is x to the 9. So that means you have to have 9 solution, that is 9 roots. So x equals 1 is not enough. You have to solve all of them. Here are the 9 root solutions of x to the 9 minus 1 equals 0. X equals cis 0 degree, and that's the real one, x equals 1. Then you have cis 40 degree, cis 80 degree, cis 120 degrees, cis 160 degrees, cis 200 degree, cis 240 degrees, cis 280 degrees, cis 320 degree, cis 360 degree, and it continues. So the first 9 are the roots. Then cis 360 degree minus 360 degree is 0. That means cis 360 degree is the same as cis 0. They are coterminals. The next one will be cis 400 degree, which is cis 400 degree minus 360 degree is 40 degrees. That is cis 400 degree is the same as cis 40. Then the next one will be cis 440 degree. 440 degree minus 360 is 80 degree. That means cis 440 degree is the same as cis 80, and so on. This continues to infinity. Basically, these are the 9 roots. Then you circle around for infinity to get all the other infinity roots, which are the same ones. They go from cis 0 degree to cis 320 degree. 9 of them. So basically, x to the 9 equals 1 is not enough. We have to have x to the 9 equals 1 plus 0i, and that's a complex number, where 1 is a real and 0i is imaginary. That means x is 9th root of 1 plus 0i. That is equal to 9th root of cis 0 equals cis beta, and we'll know what beta is. Notice r cis theta plus equals r cosine theta plus I r sine theta. R cosine theta is x, r sine theta is y, that is x plus iy, where x is the real and iy is the imaginary, and that is a complex number. And here are the detailed solution. So the obvious, we start with the obvious. X to the 9 minus 1 equals 0. X to the 9 equals 1. Take 9th root of both sides. X equals 1. That's one of the roots, so that's one of the solution. Now to find the other root, use Trigonometry De Moivre theorem to find all 9 roots, all 9 solutions. And we start with x to the 9 minus 1 equals 0. That is x to the 9 equals 1, but that is, we have to write this as a complex number. X to the 9 equals 1 plus 0i, which is x plus iy. So now we need to find the magnitude r and the direction theta. This is a vector. So x equals 1, y is 0, then r is square root of x squared plus y squared, which is Pythagorean Theorem. That is square root of 1 squared plus 0 squared. That gives us r equals 1. That's the magnitude is 1. Now the direction, for that direction, x equals 1, y equals 0. That means tan theta is y over x, tan theta is 0 over 1. That is tan theta is 0. That means theta is tan inverse of 0, which gives theta equals 0. So that means x to the 9 equals 1 plus 0i. That means x is 9th root of 1 plus 0i. That is equal to 9th root of r cis theta. That is 9th root of r is 1, theta is 0, so that is 9th root of cis 0. And that's equals cis beta. And we'll find what beta is. So we're going to use De Moivre theorem to find all 9 roots, that is solutions. So De Moivre's theorem says beta equals theta plus 360 degree k over n, where theta we found it is 0 degree plus 360 degree k over n. N is the root, which is 9. So that is 0 plus 360 k is 360 degree k over 9. Divide both sides by 9, then beta is 40 degree k, where k is equal to 0, 1, 2, 3, and all the way to infinity. So when k is 0, cis beta equals cis 40 degree k. But k is 0, so that's cis 40 degree times 0, which is cis 0 degree. That is cosine 0 degree plus I sine 0 degree, which is equal to 1. When k is equal to 1, cis beta equals cis 40 degree k, but k is 1, so cis 40 degree 1 times 1 is cis 40 degree, that is cosine 40 plus I sine 40. When k is equal to 2, cis beta equals cis 40 degree k, but that k is 2, so that is cis 40 degree times 2, which is cis 80 degree, which is cosine 80 degree plus I sine 80 degree. When k equals 3, cis beta is equal to cis 40 degree k, but k is 3, so this is cis 40 degree times 3, which is cis 120 degree. That is cosine 120 degree plus I sine 120 degree. When k is 4, cis beta equals cis 40 degree k, but k is 4, so that is cis 40 degree times 4, which is cis 160 degree. It equals cosine 160 degree plus I sine 160 degree. When k equals 1, cis beta is equal to cis 40 degree k. K is 5, so this is cis 40 times 5, which is cis 200 degree, which is cosine 200 degree plus I sine 200 degree. When k is equal to 6, cis beta equals cis 40 degree k, which is cis 40 degree times 6, that is cis 240 degree, equals cosine 240 degree plus I sine 240 degree. when k equals 7, cis beta equals cis 40 degree k, which is cis 40 degree times 7, which is cis 280 degree, that is cosine 280 degree plus I sine 280 degree. When k equals 8, cis beta equals cis 40 degree k, which is cis 40 degree times 8, which is cis 320 degree, which is cosine 320 degree plus I sine 320 degree. Now if you want to know the rest, for example, k equals 9 gives you cis beta, that is cis 40 degree k, which is cis 40 times 9, which is cis 360 degree, which is the same as cis 0 degree. They are coterminals. For 10, k equals 10, cis beta equals cis 40 degree k, which is cis 40 times 10, which is cis 400 degree, and that is equal to cis 40 degree. They are coterminals. K equals 11, cis beta equals cis 40 degree k, which is cis 40 times 11, which is cis 440, that is cis 80 degree. They are coterminals. And so on. It continues to infinity. Now you can use technology TI-84 plus to check the root solutions. Cis 0 degree to the 9, which is cosine 0 degree plus I sine 0 degree to the 9, that will give you 1 plus 0. In fact, you don't need calculator here. It is cosine 0 is 1, sine 0 is 0, so that's 1 plus 0 to the 9, which is 1 to the 9, which is 1. Cis 40 degree to the 9 in TI-84 plus, it will give you, if you put this cosine 40 degree plus I sine 40 degree to the 9, you will get 1. Cis 80 degree to the 9 is cosine 80 degree plus I sine 80 degree to the 9 is equal to 1. If you put cis 120 degree to the 9, that is cosine 120 degree plus I sine 120 degree to the 9 equals 1. If you put cis 160 degree to the 9, which is cosine 160 degree plus I sine 160 degree to the 9 equals 1. Cis 200 degree, which is cosine 200 degree plus I sine 200 degree to the 9 equals 1. Cis 240 degree is equal to cosine 240 degree plus I sine 240 degree to the 9 equals 1. Cis 280 degree to the 9 is equal to cosine 280 degree plus I sine 280 degree to the 9 equals 1. Cis 320 degree to the 9 equals cosine 320 degree plus I 320 to the 9 equals 1. Therefore, indeed, all roots are x equals cis 0 degree, cis 40 degree, cis 80 degrees, cis 120 degrees, cis 160 degrees, cis 200 degrees, cis 240 degrees, cis 280 degrees, cis 320 degree, cis 360 degree, and it continues to infinity. And here are in picture format. So it is a unit circle. It that starts at cis 0 degree, cis 40 degree, cis 80 degree, cis 120, cis 160, cis 200, cis 240, cis 280, cis 320. It is a unit circle with x-axis is real and y-axis is imaginary. This unit circle is divided into 9 sectors, each sector with 40 degrees. And here is an example of complex number. Complex number square root of 3 plus I with x-axis is real, y-axis imaginary. This is a vector of r equals 2, the magnitude. The magnitude of the vector is 2 and the direction is theta equals pi over 6, which is 30 degrees. And that is r cis theta, which is 2 cis pi over 6, which is cis 30 degree. And that is 2 cosine 30 degrees, 2 square root of 3 over 2. So 2 cancels 2, that gives us square root of 3. And that's the real. Then 2i sine pi over 6, which is 2i sine 30 degree is 2i 1 over 2. 2 cancels 2, that is 1. 1 times I is I. So that is square root of 3 plus I. That is a complex number, and that is a vector with magnitude 2 and direction pi over 6, which is 30 degrees. Now again, if you put this in the calculator, cis 40 degree, which is cosine 40 plus I sine 40 to the power of 9 gives you 1. If you put cis 320 degree, which is cosine 320 degree plus I sine 320 degree to the power of 9 gives you 1. And here, the first thing what we need to do in this calculator is, of course, turn it on, then go to mod, then make sure your calculator is in degree mode, because we are using degree, and make sure your calculator is in complex numbers mode. This is real. Then you have a plus bi is complex. So after that, quit from here, then open parenthesis, then cosine, we're going to start with 320 degree, cosine 320 plus, open plus I is second, I is here, so cosine 320 degree plus I sine 320 degree, close it to the power of 9. So that's cosine 320 degree plus I sine 320 degree to the power of 9, and that should give you 1. And here it is 1. Then we'll do second enter to call the last entry, second enter, then just simply change 320 into 280 degree, 280. And hit enter, you should get 1. Now you get here 1 minus 8 times 10 to the minus 13. This is because the calculator is using sub approximation, and this is 10 to the minus 13 means 0.000000 all the way to 13 zeros, and that is 0. This is due to approximation. This is really 1. This is 0 really. Second enter, then change this to 240 degree. This should give you 1. Again, it is 1 minus 2e to the, which is 10 to the minus 13, which is, this is really 0. It is due to approximation, so this is really 1. Then change this to 200. Again gives you 1. 1 plus 4 times 10 to the minus 13, which is, this is 0. Second enter again to call the last entry, then change this to 160 degree. 16. Hit enter, and here it is again 1. Second enter, again change this to 120. Again you get 1. Changes this to 80 degree. Which is again 1. Second enter, now it's 40 degree. This gives you 1. Then second enter 0 degree. Again, for 0 degree you do not need a calculator. Cosine of 0 is 1, sine of 0 is 0. So that means cosine of 0 is 1, sine of 0 is 0, so that is 1 plus 0, which is 1, to the power of 9 is 1. Here it is. Now if you have, for example, x to the 100 minus 1 equals 0, you will take this unit circle and divide it into 100, each sector with 3.6 degree. If it is x to the 1000 minus 1, you will take this circle, unit circle, and sector it to 1000, which each sector is 0.36 degree. and so on. And thank you. Please subscribe, share and like, and ask your friends to subscribe, share and like.